Okay, experimental and theoretical probability. Okay, first of all, first definition we're going to talk about outcomes. We talked about outcomes yesterday, but actually outcomes are the results that can happen during our experiment. Okay. Another term we're going to talk about today is sample space. Sample space is pretty important because it's going to allow us to see the possible outcomes out there. If we did heads or tails, what are the possible outcomes, Zach? So the outcome is either what? Heads or tails. Those are our only possible outcomes. Now, when we get into theoretical probability, what's theoretical? What's theory? What's that going to mean? Yes? Not so much it's a guess, but it's backed up with previous evidence, and also it's what's the ratio of the probable thing that's going to happen. If I flip a coin 2 times, we could pretty much theoretically say one time it's going to be heads, one time it's going to be tails. If I roll a die 6 times, we would say theoretically a 1's going to show up once, a 2's going to show up once, a 3 will show up once, a 4 will show up once, a 5 will show up once, a 6 will show up once. That's our theoretical probability. Does that always happen? No. When it does not happen, that's when we actually do it. Experimental probability. Okay? Based on the experiences that when we actually do the activity or the experiment, whatever it may be. We actually roll a die or dice or flip a coin or draw marbles out of the bag. Okay? All that will depend on the experimental part of it. Now, and the more times you do experimental, the more times it'll match up with theoretical. Okay? Okay? Any questions? Any questions over this? Are we done with this part? This is in our book on 13.1. Okay, 13.1, it has the definition. Okay? Now, as we move on, I'm going to show you some examples here. Okay, we have a mad scientist here. And data is collected through observations or experiments. Experimental probability. Okay? Each result is called an outcome. Okay? You don't need to really take this down. It's just kind of some ways to show it to you. Probability of an outcome is equal to the number of times that success occurs divided by the total number of trials. We just talked about that yesterday when we said a P event, P, whatever the event is, red marble, head, tails. If you're rolling one die 5, that'll tell you probability of 5 would be the number of successes over the total number of outcomes. Okay? Possible outcomes. So we got a guy here shooting free throws. Okay? Now, number of successes over number of trials. He's going to shoot a couple times. So if the event of scoring a basket is the number of baskets over a number of shots taken. Okay, so let's see how he does here. Well, the first time, he's going to shoot, and he misses it. Okay? So now what is he? He would be 0 for 1. Second time, he shoots it, and, okay, he's 1 for 2. Now this time, he shoots it. What do you think? Oh, that's what we would call a brick. Okay, not very smooth. Bricked it off the backboard, and he didn't make it. So he's what? 1 for. So he is shooting right now. What percentage? 33%. That's not bad from half court. Maybe not bad from 3-point range. But layup or a 5-footer, which it looks like he's a little closer, probably not so good. Okay? Now, that's the experimental of shooting a basketball hoop. We've talked about theoretical probability. We just talked about heads or tails. When a possible event or outcome are equally likely to occur, theoretical probability can find without collecting the data. What is theoretical probability of heads or tails? We said was 1/2, right? Heads half, tails a half. Okay, we good with that? Yeah. All right. All right, rolling a die. What's rolling a die? How about this? The die is rolled. How many possible outcomes are there? How many are there? 6. Okay, makes sense. 6. What is the theoretical probability that you'll throw a 6? 1 out of 6. What is the theoretical probability that you'll throw a 2? Okay, makes sense. 1 out of 6. What is the theoretical probability that you'll throw a 7? 0. And what is the theoretical probability that you will throw an even number? And what are those even numbers? 2, 4, 6. So it would be 3 out of 6, which would be simplified into a half. Very good. We also have probability in spinners. Now, this is a little wide, I understand here. What is the favorable outcome? Candy. Okay? What is the theoretical probability of winning candy? 2/3. So 66% if we did it as a percent. What is the sample space? What are the possible choices? Candy or veggies? Would this be a fair game? No. Okay? Now, if you wanted candy, you might set it up where it rigged up to where you're going to get candy. Now, is this fair or not fair? Why is that? Player 1 is going to get 50%. So, probability of player 1 winning is player 3, player 4, player 4, 0. Player 2, 50. Okay? Fair game? No. What did I say? Okay, sorry. So, what we'd have here, if we looked at this, 25% chance, or 1/4, 25% chance, 1/4, and then we'd have 50% chance, 1/2. Now, if you have a younger brother, younger sister, younger cousin, you might be this person, and you might make them that. Okay? Them not really knowing it. And then you have a little younger one that's player 4, and you say, well, you might have a chance of winning out here. Never. Okay? All right. Now, that could happen. Okay? Yeah, there might be a little bit of a chance, but probably not. Okay?